Example number 3. Show that the binomial expansion of this up to and including the term in x cubed is given by this. Alright, so we're doing another binomial expansion. However, our power, look at the power. In our previous examples, our power was a positive integer, and the formula we were using could only be used for positive integers. I had mentioned that before. This is positive, but it's not an integer, and so the formula we were using cannot be used for this particular example. There's another formula that is also on the formula sheet. I'm going to copy and paste it here so that we can dissect it and see what it is, what the conditions are for its use. Right? This is a formula that is found on your formula sheet. This is important to note that we use this one when the power is not a positive integer. Now, technically it can be used for any real number, but there are some more conditions on it that I prefer this one when the power that we're working with is not a positive integer. So in this case, 1/5 is not a positive integer, so this is the formula we want to use. Now, the thing about using this formula, if you look, we no longer have a plus b, which basically means any two things added. Here we have 1 plus x. This 1 here is very important, which means in our bracket, in order to use this formula, there needs to be a plus 1. If there is not a plus 1, we cannot use the formula as is. We cannot jump straight to using the formula, right? There has to be a 1. And then there can be a plus x, minus x, or in this case, a plus 5x, etc. But the 1 here is critical. We do have the 1 for this, which is wonderful, which means we can jump straight into using the formula. So let's look at the formula. It starts with 1 plus n times the x term plus n times n minus 1 over 1 times 2, and then the x squared term. I can just fill in. Let me do one more before we look at the pattern. The next one, if you're seeing the pattern, would be n times n minus 1 times n minus 2 over 1 times 2 times 3, etc. Right? Let's do one more. Times the x cubed term. So the fourth one would be n times n minus 1 times n minus 2 times n minus 3 over 1 times 2 times 3 times 4, and then the x fourth term. Right? I said the fourth term, but it's not the fourth term. It's actually the fifth term. It's the x to the fourth term. So you have your constant, then your x term, then your x squared, then your x cubed, x to the 4, x to the 5, and so on and so forth. All right? Now, this question only requires up to go to the x cubed term. So we're going to be following the pattern going up to the x cubed term. So our 1 plus 5x raised to the 1/5 is equal to 1 plus, our power is 1/5, so our n is 1/5. So 1/5. Now instead of having x, we have 5x, right? What's in our bracket is a plus 5x. So we would replace all the x's in the formula with 5x plus n times n minus 1 over 1 times 2 times the 5x being squared. Remember, we're replacing the x in the formula with 5x. So 5x is squared, and sure it's in brackets. I spoke about that before. Plus 1/5 times 1/5 minus 1 times 1/5 minus 2 over 1 times 2 times 3 times the 5x being cubed, right? And it's not stated here in this formula, but if you look at the denominator, this is actually 2 factorial. This is 3 factorial. So you're actually dividing by factorials. This is over 0 factorial, over 1 factorial, over 2 factorial, 3 factorial, and so on and so forth. All right, so let's use our calculators to work these out. This is going to be 1 plus 1x plus, so this is 1/5 times 1/5 minus 1 divided by 2, because 1 times 2 is 2, and that gives me negative 2 over 25 times this 5x all squared is going to give me 25x squared plus, next one, 1/5 times 1/5 minus 1 times 1/5 minus 2 divided by 236. That gives me 6 over 125 times the 5x being cubed is going to give me 125x cubed. And then simplifying, we're going to get 1 plus x. This 25 cancels this 25, leaving us with minus 2x squared plus this 125 cancels this 125, leaving us with 6x cubed. And this was a proof question, so we can see that we end up with exactly what we wanted. So let's put shown. There is a part 2 to this question. It says, hence, by letting x equals negative 1 over 32, compute an estimate of the fifth root of 27. They gave us the x value that we're supposed to use. So what we've just shown that 1 plus 5x to the 1/5 is equal to 1 plus x minus 2x squared plus 6x cubed. Then they said we are to let x be negative 1 over 32. So I'm going to say when x equals negative 1 over 32, let's plug that in. So 1 plus 5 times negative 1 over 32 raised to the 1/5, right? So we're plugging it into the entire equation, both the left side and the right side. So we're plugging the x here, and we're going to plug it in these places as well. So that is equal to 1 plus x minus 2 times x squared plus 6 times x cubed. Now let's work out what's in the bracket. Let's see what we get when we calculate 1 plus 5 times negative 1 over 32. 1 plus 5 times negative 1 over 32 gives me 27 over 32. So I have 27 over 32 being raised to the 1/5 power. And remember, 1/5 means the fifth root. Good. Let's work the right side now. So that's 1 minus 1 over 32 minus 2 times negative 1 over 32 squared plus 6 times negative 1 over 32 cubed. And I get 0.967. All right. Now, we don't stop here because the question asks us to estimate the fifth root of 27, which means we have some more work to do because what we have on the left is the fifth root of 27 over 32. So let's split this up. This is actually the fifth root of 27 divided by the fifth root of 32, which means we just need to make the fifth root of 27 the subject by taking the fifth root of 32 and multiplying it on this side. Well, the fifth root of 32 is 2, so it's going to be 2 times 0.967. Therefore, the fifth root of 27 is 2 times 0.967 gives me 1.93. Right? And we can check the actual value to see how close we are. If we're far, then probably we made a mistake somewhere. So let's find the fifth root of 27 on our calculators. And I get a value of 1.93. So I feel confident about what I did.